finding molar mass from chemical formulae. So we're going to really make sure we understand what the subscripts and parentheses stuff means in chemical formulae. Okay, so to work out the molar mass of a compound as opposed to just a single element, you have to add together the molar masses of the individual elements of the compound, and you have to do this for each one of those elements of the compound. So for example, here we have one zinc, but then this NO3 unit, the nitrate unit, look outside the parentheses, that's telling us there's 2 times the nitrate units, okay? So that means we've got 2 times nitrogen and 2 times the 3 oxygen that is in the O3, so that's going to be a total of 6 oxygens. So it's always a good idea to sort of do a little bit of bookkeeping and say, well, I've got 1 zinc atom, I'm going to have 2 nitrogens, and I'm going to have 6 oxygens coming from the 2 times 3. Okay, just to remind yourself before you start adding them together. So look up zinc on the periodic table. So molar mass of zinc nitrate is going to be 1 times, and then zinc's over here, 65.38, I think that says, grams per mole. And then we've got 2 nitrogens, so 2 times fine nitrogen over here, 14.007 grams per mole. Yep. And then finally, oxygen, we have 6 oxygens, and that should be 15.999 grams per mole. Okay, obviously for these kind of questions, it is pretty important that you actually use the ALEKS periodic table to make sure you get the right number of significant digits in the molar mass of elements that you are using. So 1 times 65.38 plus 2 times 14.007 plus 6 times 15.999. Okay, make sure you can enter that in your calculator using parentheses like I've done, just to make sure it does it right. So 189.388 grams per mole. What about rounding, etc.? So just as an FYI, if I was going to ask you to round this, I would say, well, if you're adding stuff together, then you would go to the smallest number of decimal places. The multiplying by an integer here doesn't count, right? Because that is an exact number, so it has infinite sig figs. So I would say that you should round to 2 decimal places if you were going to round. But ALEKS has asked us to round to 1 decimal place. So 1 decimal place would be here. So that's going to be 189.4. Okay. So let's have a look at another one then. What else do we have? All right, that is the same one. So let's not do that. That would be a bit of a moot point. Okay. So other things to look out for in chemical formulas would be when you have an element appearing in more than one place, like in this methanol formula here. Now, this is a great example of a structural formula, which is used often in organic chemistry to show like how things are linked together in the molecular structure. Okay, so look, we've got hydrogen in 2 places here, and that's telling us that these 3 hydrogens are bonded to this carbon and this hydrogen is bonded to this oxygen, which really helps when you're trying to actually draw the structure. But for now, it's a bit of a pain when you're trying to work out the molar mass, right? So we have got 1 carbon atom, we've got 4 hydrogen atoms, sneaky, and we've got 1 oxygen atom. Okay, so the molar mass then of my methanol is going to be 1 times carbon, which is 12.011 grams per mole. And then I've got 4 hydrogens, which on this periodic table is 1.008 grams per mole. And then I've got 1 oxygen, which is 15.999 grams per mole. All right, so you can add those all together and get your molar mass of the methanol, which should come out to be 1 times 12.011 plus 4 times 1.008 plus 15.999 should come out to be 32.042 grams per mole. So if I was asking you to round, they've been added together, so I'd go to smallest number of decimal places, which is 3. You were asked around to 2 decimal places to answer the question, so boom, there we go. All right, so let's see what other kinds of fun stuff we have in here. Anything really sneaky? Oh, this is super sneaky. We've got both things happening at once here. Okay, so where's my periodic table gone? Come back to me. Sorry about that. So we have got carbons and hydrogens in more than one place, and we also have parentheses. Okay, so what that is telling us is that we have 2 repeats of this CH3 CH2 unit. Okay, so if I was going to write the whole thing out, like CH3 CH2 CH3 CH2 SO, right? So we got lots of things to add together here. So how many total carbons have we got? 1 carbon, 2 carbon times 2 for the parenthesis, so that is going to be 4 carbon atoms. Okay, and then we got 3 plus 2, which is 5 hydrogens, but then that whole unit's times 2, so that is going to be 10 hydrogens. And then we've got 1 sulfur, and then we've got 1 oxygen. So there's quite a few things to add together there, right? So the molar mass is going to be 4 times 12.011 grams per mole, the carbons, and then we got 10 hydrogens, which was 1.008 grams per mole, and then sulfur is over here, 32.066, so 1 times 32.066 grams per mole, and then last but not least, oxygen, 1 times 15.999 grams per mole. So add those all together. What do we end up with? A number, hopefully. Right, so 4 times 12.011 plus 10 times 1.008, be careful with parentheses, etc., plus 32.066 plus 15.999 gives me 106.117 grams per mole. And I would round that to 3 decimal places, which it already is. We're asked for this question to do 1 decimal place, which would be here, like so. And just remember, you can, when you're going to then go on with this and do some kind of moles calculation, get used to writing that out as an equivalency. So every 1 mole of CH3CH, whoopsie, my didn't get a capital H, CH3CH2 subscript 2 SO, or if you prefer, diethyl sulfoxide, weighs exactly 106.1 grams. So then you could take that and use it in your moles calculation. All right, that'll do on that one, I think. So just get some practice, watch out for elements in more than one place, and watch out for parentheses.